Okay, so let's look at the point slope form. I like to think of this as the worker form. This is the one that goes on behind the scenes that we don't see a lot, but it's very, very useful in building our lines because it incorporates a couple of situations we find ourselves in most often. Okay, so if we have a line with slope m, which passes through the point x0, y0, then the line is given by y minus y0 equals m x minus x0, where again we have our point that we know, x0, y0, and we have the slope m. The x and y are the variables that will be left in the equation. All right, so the x0, y0 are specific values, a point that we know is on the line, and the y and the x are left to be any other point on the line. Okay, so if I'm told I have a line with slope m equals -4 that passes through the point 1, 3, then I could easily convert that, because this is going to be what I'm going to call x0, y0, and some people refer to this as x1, y1. It doesn't really matter. It's just specific x value and y value. So I'd have the y minus the y0, 3, equals -4, your slope, times x minus the x0, 1. Okay, so let's take a look and let's see, let's graph this, practicing our graph sketching. Okay, so let me get a set of axes going here. And let me see, let's do 1, 2, 3, 4. Okay, so let's see. All right, so what I see right now is I definitely have a slope of -4. Now again, when we're talking slopes, this is a case where we like fractions. Yes, we like fractions because we want it in a y over x form. So -4 over 1 is one way to think about it, or 4 over -1. Okay, so those will both be useful for us. Okay, so in this time, since we're given the point 1, 3, so we'll find the point 1, 3 right there. Okay, and now we're just going to use our slopes, well, our slope in our different forms, to move off of that point. Okay, so the -4 over 1 says we would go down 4 to the right 1. So down 1, 2, 3, 4 to the right 1, and that will land us here. So those faint dots there are just my path going to the point, and the darker ones are the actual point on the line. Okay, so I could go and move down again, but I actually have 1, 2, well, yeah, I could go down 1, 2, 3, 4 over 1. All right, but again, it's nice to be able to build my line the other way, and that's how I could use the 4 over -1, meaning I could go up 4, 1, 2, 3, 4, and then back to the left 1, and put me right there. Okay, so let's see. Let me put this line in here as best as I can draw it. Oops. Okay, so that's this line here. Now, notice I ended up, looks like on the y-axis at 1, 2, 3, 4, 5, 6, 7. Well, let's check. See, we could always take this form and multiply it out. Y minus 3 equals negative 4x plus 4. Y equals negative 4x plus 7. So what I've done is I've converted it into the slope-intercept form, and lo and behold, I see that, yes, 7 is my y-intercept, so I correctly found it the other way. So I didn't need that form. I was able to do it from the point-slope form. So this leads me to a question. While I'm saying that this is a very useful form for getting a line equation because you basically just have a point and a slope, it's rarely used as the final form. Okay, so why do we usually prefer the line to be ultimately given in slope-intercept form rather than point-slope form? Well, there's a very good reason here. And the answer is, for a given line, slope-intercept form is unique. In other words, there are a lot of different point-slope forms for a specific line, but there's only one slope-intercept form. Now that makes sense because if you think about it, slope-intercept form is really just a special case of the point-slope form. It's the special case where the specific point you're using is the y-intercept. So realize that the y-intercept that we're calling b is really just the point 0, b, because that's when y is b and x is 0. So it's really just choosing one specific point to be the point in your point-slope form, and hence then you get the slope-intercept form. All right, so as we can see, if I take a look at these seemingly two lines here, I can't tell whether they're referring to the same line or not. But if I were to multiply it out, it's negative 5x plus 5, y is negative 5x plus 2. Over here, y plus 8 is negative 5x plus 10. Y equals negative 5x plus 2. So indeed, these are the same, whoops, they're not the same line, they're the same line. Okay, so while that was difficult to see from the original point-slope forms, easy to see from the slope-intercept. So that's why we often like it. So we like it as the final answer because if we all put our answer in the slope-intercept form, we'll see the same thing, but we might not from point-slope. So let's look at an example here. And this is one of the most important examples in dealing with lines. Find the equation of a line passing through these 2 points. So this is a very common situation. You have 2 points and you want to figure out what's the equation of a line passing through them. So I like to think of it this way. Whenever you're trying to create a line, you need 2 things. You need a point on the line and you need the slope of the line. So if you ask yourself for any problem, do I have these things? So do I have a point on the line? Well, yes, I actually have 2. And I could use either one of them eventually, but I have 2, so I have at least 1 point on the line. Slope, no, I don't, but it's a simple calculation away because if I do my slope as my y2 minus y1 over x2 minus x1, all right, so negative 1 minus 2 over 6 minus negative 3 is negative 3 over 9, or negative 1/3. So now I do have the point and the slope, so I could go ahead and use my point slope form, y minus y0 is mx minus x0, and just fill these values in. I need to just use one of these 2 points, and I'll go ahead and maybe I'll use the second one here. So y minus negative 1 equals m. Oh, and we know the slope is negative 1/3 x minus 6. And so let's multiply this out. Y plus 1 is negative 1/3 x. And then the negative 1/3 times the negative 6 gives me a plus 2. And then so finally, if I move the 1 over, y equals negative 1/3 x plus 1. And that is the equation of my line. Now, if you don't like to use the point slope form, once I got the slope and in this case, what I could have done is I could have gone and said y equals mx plus b, all right, and then used one of the points, so negative 1, I'm using the point 6, negative 1, equals the slope, negative 1/3 times x is 6 plus b, all right, and that would be negative 1/3 equals negative 2 plus b, and then solving for b, I'd get 1 equals b, or b equals 1, and that way I have the y-intercept, and I could use the y-intercept and the slope just to directly get y equals negative 1/3 x plus 1. So that's an alternate way that you can go about it rather than using the point slope form.